Hello everyone, this is our brief video for our sampling distributions overview. So part of the reason why I'm saying this is brief is because what you should be putting on this overview should be guided by you. That's how I should say it. There is not necessarily any right or wrong way to do this. This is a map for you to gather all of the important information from this unit. So the definitions you add, the explanations you add should really come from you, and they should be things that you feel good about. Now, you're welcome to use what I uploaded because I wanted to give some of you guys an idea of what this was because I hadn't put the video up yet. So, pictures of my sampling distribution. This bang is like driving me bananas. Pictures of my sampling distribution overview are posted for you, but I would highly encourage you to not just copy it, to actually go through and add things that would benefit you and enhance your understanding. So remember, this is just the map, but you should be the one in charge here. You will turn this in, so keep that in mind. I do want to see that you did this. You will turn this in and your review in. So, there's a couple of things that I want to highlight. The first thing is, it's important that you guys understand the difference between X bar and P hat. And the reason that that is important is because when we go to this other side of our paper, the conditions that you check for each are different. Now, some are similar, and that's what you're seeing here with my highlighting. So I'm trying to indicate to you guys that for your mean of your sampling distribution, those are determined by random sampling, whether you have X bar or P hat. And you can calculate the standard deviation of your distribution by verifying the 10% condition, regardless of whether you're doing X bar and P hat. So the highlighting here is the same because the condition is the same. What is different is what makes your distribution normal. So you need to make sure that you memorize and keep track of. If it is P, you're checking large counts condition. And if it is X bar, you're checking central limit theorem. And then I have the details there on those. You almost always are asked a question regarding n less than 30 and n greater than or equal to 30. Just like in your lesson quiz, it tells you sample size is 40, what's the shape of the distribution? Sample size is 10, what's the shape of the distribution? It's very similar to your lesson quiz. You will absolutely have a multiple choice question just like that. So make sure that you feel good about this idea, and if you need an example of that, look at your lesson quiz. It's going to be just, well, not just like, but very similar to that. The other thing that I want to highlight here is that notice that I have now added in this phrase, it is reasonable to assume. Now that we're comfortable, hopefully, with this process of checking conditions, I want to add in one more element to beef up our response, and that is to make sure that we are including the phrasing, it is reasonable to assume that n is less than or equal to 1/10 n. I have that shown here, and I highlighted it in the same color. You probably can't tell because this camera isn't awesome, but I've folded in this new thing into my responses here, and I have also done that for my responses to the Unit 5 review. So back to the front. Is there anything else that I want to highlight? How do you know if an estimate is biased? the mean of the sampling distribution does not equal the true value of the population. How do you get an unbiased estimate? The only way to do that is to take a random sample. Why do we often look at the center of a distribution when determining an estimate is biased if up here the definition is the mean has to equal the value of the population? So why do we always refer to center? Because it is quicker and easier to use the median to estimate the mean of a population. So this is where I would go to this paper and add in some extra elements to this paper. So for instance, this is an unbiased estimate. If you're in 1A, you guys estimated that the average of this distribution was 15.2. Really, it's 15.4. This is and was intended to be centered at the true value. So the true center and mean of this distribution is 15.4. So this is an example of an unbiased estimate. Whereas both of these are biased. That's where these examples came from. It was from the lesson when we were investigating biased or unbiased estimates. And what you need to recognize is that the average sample value should equal the true value. Average sample value should equal true value, but in this case, we use the median as a shortcut. So I would maybe come through on this paper and add in things now that come from here that I know that I need to know. So I could add in, this is a biased estimate. This is a biased estimate. This is unbiased. Okay. This whole section is really important. Make sure that you feel good about describing what a point represents on a sampling distribution and what qualifies as plausible or not plausible. So remember, your cutoff for plausible is 5%. So plausible, I guess I could add this in, is greater than or equal to 5%. Not plausible is any value less than that. So when it says, explain how you determine that getting a p-hat greater than 70% is not plausible, well, because above in our dot plot, 9 out of 50 were that value or more. So not plausible, that's 3%. We refer to this as convincing evidence, and we would reject the claim. So if it asks you if you believe something or if there's convincing evidence, you always want to make a plausible or not plausible statement. And it's good if you mention convincing evidence or not convincing evidence. The only thing that I would add to this overview to make it better is something along the lines of a magazine claims that half of people should expect to wear braces at some point. A news magazine or a news article claims that half of people will have to wear braces. Do you believe or not believe? Well, let's go to 50% on our dot plot. So 50% and below is 5 dots. 50% and above is the other 250 dots. So the probability that at least half of the people would need to wear braces at some point is 248 out of 250. The probability that at least half of people will have to wear braces is 248 out of 250. In our sample, out of 250 samples, the proportion was less than half of people 2 times. So do I believe that magazine article's claim? Yes. I believe the magazine article's claim. It is plausible that half of people will have to wear braces because our dot plot shows that almost 100% of our samples had a proportion of at least half. I would feel really good about answering that question. A magazine claims. So actually, I'm going to write that in up here. And so I'll pause, I'm going to write it in, and then I'm going to come back. Okay, I'm back. If you're watching this video and you add this in, I believe you will be rewarded on your test. So, here's the claim. A magazine claims at least 50% of teenagers will wear braces. So this is data on teenagers in the United States who have worn braces to straighten their teeth. They were asked the question, did you have to wear braces? And I would assume did you have to wear would include if you're currently wearing them. Of our 250 samples of teenagers, only 2 of them had a proportion where less than half of them said yes. So, here's how you should answer, do you believe this claim? Here's how you should answer, do you believe this claim? And here's how you should answer all of these kinds of questions. This is not convincing evidence against the claim. So in this case, you might say, this is not convincing evidence against the magazine's claim. Because the dot plot shows the probability of getting a sample of at least 50% is like 100. It's almost certain that at least half of teenagers have to wear braces. So you end with, it is plausible that 15%, that, I guess I should say, at least 50% of teenagers will have to wear braces. So the only way to make this overview better would have been to add a question that specifically asks you to evaluate a claim. If you're asked to do that, you say there is or isn't convincing evidence based on a percent calculated from the dot plot. Whatever that percent is tells you that it is plausible or not plausible to get what the claim says. Okay, conditions for checking. Hopefully you guys feel okay about that. On these 2 problems, the only reason that I had you identify N is because it is important you know what N is to check standard deviation. So note, you would not ever do this twice. I only had you do this so that you were prepared to write this. So this is all you would get for the question. So I just want to highlight the N is all U.S. college students, so it is reasonable to assume 30 is less than 1/10 of that. Here's my work and my formula for calculating this probability. Oh, speaking of, if you're in 1A, I need you to change these numbers to 16 and 18. I believe for you it was 14 and 20, and those numbers give you z-scores that are so big that you can't use your z-table for it. So if you're in 1A, you need to change your summary to say, or your overview to say 16 here and 18 here. I added in the formula for z here, and for standard deviation of x here. Same with this, standard deviation of p hat, z for p hat. And then this is the solutions to the problem. So the one last thing that I want to say before I leave the overview is for the multiple choice and part of the free response, this is your map. There is nothing in the multiple choice that is not addressed here on this paper. And there's part of the free response that's addressed here. Well, kind of addressed. Definitely addressed if you add in this magazine claim and how you would answer it. So, this is a really good map for what you will need to know. If there's any confusion on this, email me or ask me when we get to be in class together and talk about this. I think that that's it for this video. You should now do your review, do this review, and you should probably use on this review this overview. Like I would maybe have just these 2 sheets to answer this, and anything you can't answer from looking here, you should add to this sheet. You should smash it in somewhere. So if you need to go to your notes and find something that's not on either of these papers, you should add it to these papers or make a flashcard and include that in your studying. Okay, that's it. Love you guys.